In this lecture presented by www.free-academy.com, we're going to be tackling another problem submitted by one of our students. Now this is a bit of an interesting problem, and it's about stocks. And we've been given a function r of t equals 250 t squared divided by e raised to the 3t power, which I've written here using the more familiar x. Just notation I like to use. R of t, or f of x, is the overvaluation of the stock in percentage, and t is in months. And we're supposed to use our tools for minimums, maximums, and inflection points to predict when we should buy or sell the stock. So you can read out the actual paragraph, but we're going to go through and do the calculus now. If you want to read, just pause it. In any problem, we're always going to need a first and second derivative, so f prime of x is going to equal 500x e to the negative 3x plus 750x squared e to the negative 3x, which we can then write as 250 over e to the 3x, 2x plus 3x squared. And then we'll need a second derivative as well. And I'm going to pause it and just write out the actual derivative because you don't need to watch me do it. Alright, now that we have our two derivatives, we need to find where they're equal to 0, so that way we can do our first and second derivative test. Now if you take a look at the first derivative here, there's no point where e to the negative 3x is going to be equal to 0. It just never happens. The only closest you'll ever get is an infinity. Positive infinity would take this to 0. But we're not really dealing in those. Although that is a horizontal asymptote, if you like, x equal or y equals 0. At any rate, first derivative is going to equal 0 when this polynomial in the bracket equals 0. Now seeing as both of these have a common term, which is x, we know that one is going to be 0. And if you take a close look, you're going to find that the other one will be 2/3. So now we'll set up a table. Negative infinity to 0, 0 to 2/3, and 2/3 to positive infinity. And we'll pick some test values, say negative 1, 1/2, and positive 1 should work quite nicely. And if you put these into the first derivative, replace x with negative 1, and use a calculator, as I did, you should get negative 25,106.9, 13.95, and negative 12.477. which this in turn is negative, positive, negative, decreasing, increasing, decreasing. So you have a minimum at 0, and then you have a maximum at 2/3. But of course, time can't be negative, so this is all fairly irrelevant over here anyways. And also, I want to point out that if you put 0 into the function here, you get 0 out. So this is going to start at the origin, and it's going to increase, and then it's going to decrease at some point. And it's never going to touch the x-axis again as well, because there's no other zeros for 250x. So that's what we know from our first derivative test, that we have a maximum that occurs at 2/3. Now let's go on and let's tackle our second derivative test. It's going to be the same story where this polynomial is equal to 0, so is our function. And that's going to occur when we have x equal to 2 plus or minus the square root of 2 over 3, which is approximately equal to 1.14 and 0.2. So we'll set up this table. Negative infinity to 0.2, 0.2 to 1.14, and 1.14 to positive infinity. Well, it's the same story as always. We pick some test values, say 0, 1, 2. We plug these in, we get 500, negative 12.45, and 8.68. Positive concave up, negative concave down, positive concave up. So we have an inflection point that occurs at 2 plus the square root of 2 divided by 3. 2 plus root of 2 divided by 3. And also at 2 minus square root of 2 divided by 3. But there's also something I want to point out here. Between 0 and our first inflection point, not only are we increasing, as we've already determined, but we're accelerating really rapidly. That's a really rapid increase in the increase, which might be important for the stockholders to know. So based on what we know on inflection points, our maximums and our x-axis crossings, I was able to come up with an approximate graph here. We have our first inflection point at point 2. Our maximum occurs at 2/3 and is equal to 15. And this is all decreasing afterwards, not exactly drawn to scale. At 1.14, we switch again, and then it's all concave down afterwards. So if you're going to use this information to give to clients to tell them when they should buy and sell this stock, you should tell them, obviously they want to buy low and sell high, so tell them to buy at t equals 0. Tell them a signal that they may want to sell is going to occur in 0.2 months, because this is percent. Just have those labels there. Tell them they'll want to sell in 2/3 of a month, because that's, of course, they want to buy low and then sell when it's highest, which is its max. And also, if they're dealing in futures, they'll want to buy at 2/3 month, sell at 1.14 months, or look out for a sign to sell at 1.14 months, and sell anytime after that, because there won't be another minimum again. So that's how we use calculus to play the stock market game. And real stock traders do something similar to this all the time. Of course, the equations they're given are usually not so neat, but they do work with equations all the time and use this type of math to figure out when they should buy, when they should sell. So that's this lecture by www.free-academy.com.